Okay, good morning. Welcome to
FamilyMath741a.
FamilyMath741. Today we're going to talk about something called gerrymandering. Have you ever heard this word before?
No.
No.
Neither of you have. Okay. Gerrymandering is a concept that comes from politics, actually. When you have a state that I'll approximate by a rectangle, you divide the state up into congressional districts. Okay, so maybe your state has 4. So maybe, for example, like this would be a way to divide it up.
Yeah.
Okay. But if you're a politician, what do you want to do?
Do you want to maximize your side?
That's right. You want to maximize your side. Well, probably number 1, you want to maximize your chances of being elected.
Yeah.
And then number 2, you want to maximize your team's side of being elected. So maybe you don't want to divide it up like this. What are some other reasons why you might not want to divide the state up like this that don't actually have anything to do with one side or another side winning?
Well, they're all equal.
They're all equal in what?
In the area?
Okay.
In area.
But what's another thing you might want to make equal?
Like the perimeter?
You might want to make the perimeter equal, yeah. But we're talking about
Maybe like
politics now, not
the population?
Yeah, you might want to make the population equal. So maybe if there's a big city right here, and not very many people live over here, like maybe this would be 80% of the population or something like that. And so this would be sort of an unusual distribution. And it turns out that gerrymandering is actually a very hard thing to talk about mathematically. It seems like it actually would be really easy. But it turns out to be pretty hard. It's actually surprisingly hard to talk about mathematically. But some people are starting to do that, and they're starting to study it and give some workshops and talk about it, and it's actually really interesting. And one of the people, there's actually quite a few. One of the people is a woman named Moon Duchin, who's a professor at Tufts. Do you know what's special about Tufts? No? No. Do you know where Mom went to college?
Tufts.
Tufts.
Tufts. Okay, so let's rewind. Do you know what's special about college? Or Tufts?
Mom went to Tufts.
Yeah, Mom went to Tufts. And actually, there's another fun thing about Moon Duchin. We used to live in Stamford, Connecticut. That's where she's from. Anyway, so she's been talking a lot about it. She gave a talk yesterday that generated a lot of publicity, and that gave me the idea to talk about it today. So we're going to do one exercise today that's here. If I can grab it. So here you have a state. I made 2 copies of these, so each of you can work on it on your own. The map consists of 100 squares. 40% are of which are orange. You want to divide each map into 10 contiguous, so-called compact districts of equal size. So how big? What's the size of each of your regions going to be?
I think it 1, 2, 3, 4, 5.
It says it.
Yeah.
It's 100 squares.
Okay, so they'll each be 10 squares.
Yeah.
Do they have to be like a continuous, like one region, or can there be a square here, like a square here?
Well, that's what they mean, contiguous
Right.
compact regions. So yeah, they have to be. Think of them as having to be connected.
Okay.
Such that in the first one now, how are you going to decide who wins in a region that you make?
Well, if there's more of the orange, if there's more of the orange than the purple, then the orange will win.
That's right. And if there's more purple than the orange will win. So you have 40% of the squares are orange. So how many are orange?
40 squares.
Yeah, 40 and then 60. So your first challenge is to divide it up such that the orange party wins 4 out of the 10 districts.
Okay.
And your second challenge is to divide it up so that the orange party wins 6 of the 10 districts.
Okay.
Why do you think that second one's a challenge?
Well, because you only have 40 squares, and to get winning, you have to get a majority, you have to hit at least 6 squares, so that'd be 36 squares. You only have 4 to spare, so you have to generate
Yeah.
Yeah.
Okay. All right, good. So we'll have you guys do that off camera and then come back and talk about some of the ideas and things you learned about, all right?
Okay.
Okay.
All right, we'll go to it.